Hi, my name is Archibald Nkela, and I'm from Texas, in the United States of America.
My name is Siddhan Singh, and I'm from Texas in the United States of America.
Cracks and bumps in the roads, namely potholes, cause cars to have major accidents, it burns more gas, and contributes to an increase in greenhouse gases. Drivers have to burn more gas and produce more carbon pollution to go the same distance. Crumbling streets and highways are a big problem in the United States. In 2017, the American Society of Civil Engineers gave the country's roads a D. The sorry state of US infrastructure is worsening emissions from the transportation sector, which accounts for nearly 1/3 of all US carbon pollution, according to the Environmental Protection Agency.
FOVEA AI is an infrastructure technology company in the smart highway niche that focuses on developing solutions to mitigate environmental consequences of vehicular interaction with city road networks, primarily pothole detection.
To mitigate these environmental issues and reduce our carbon footprint, FOVEA AI has developed a pothole detection device that can properly assess road conditions and aid drivers. These FOVEA is our state-of-the-art pothole detection device that uses recurrent neural networks and computer vision to provide data of the roads. We have information banks that are alerted to local municipalities where cities can take the initiative to provide a solution to roadway issues. Then we have our free mobile application that will take data from the device and will be used to integrate into GPS providers like Google Maps or Waze. Drivers also benefit through gaining custom insight and being alerted about the specific conditions of the roads they travel on and how that might impact the environment and their car. With our approach, we are creating a long-term solution and a temporary solution to reduce carbon pollution.
This is the FOVEA device we have currently, and basically what it is it's a 1080p webcam, which has a really high refresh rate, so it can take multiple screen captures per second. And then we have that connected with a Raspberry Pi, which is basically a small mini computer, where we can connect this operator with this actual motherboard. And so what I'm going to be showing you guys is basically disassembling the product assembly and then showing the component parts behind the FOVEA system. So what we have right here is the actual webcam, and so the purpose of the webcam is to actually feed in the data, and then this data is going to be transferred into this motherboard where all of the machine learning algorithms work, and all of that is run and saved. And then from there, our motherboard transfers that over through an HTTPS protocol, where that's stored into an AWS S3 database, which is basically a really simple storage solution for IoT devices. We're going to be talking about the technologies we utilize to create the FOVEA product. So starting, what this is this is the XML data files which we use to train and validate our machine learning algorithm. So as you can see on the left, we have an image. What me and my partners did was we used a software to map all the specific locations of the potholes, and what this did was it generated XML data. We did this for hundreds of files, and then we used this to test, train, and validate our machine learning algorithm. Next, what we have is our machine learning algorithm's code. And so if you want to check this out, you can type in that link in the URL header box, or you can click the link in our video description. This is not all of the code, but this is a huge chunk of it. What we have on the left is all of the imported libraries that we use to actually demonstrate our code and actually make it function on our remote IoT device. The code on the left and the right here, the apply mask and then this function, what these do is they apply different masks and filters to actually stratify the image, and then it increases the statistical likelihood of actually detecting potholes within images we capture through our video capturing device. And then in the middle, what we have is one infinite while loop, and this just keeps running, and it'll keep scanning the roads and take photos and photos to actually detect potholes, and then it uses this to send a geolocation request to our web servers, which we're going to be talking about next. So what we have as a third component is Amazon S3. And so Amazon S3 is a AWS web server storage solution built in on the cloud. So one of the really cool things about AWS is that it's built throughout the world, and so this allows FOVEA to actually store data throughout the world and map different locations and provide a more authentic and surreal user experience for all users. Amazon S3 is a really cheap and effective way of storing huge amounts of data, which is what our FOVEA devices are going to be producing.
Now behind the entire pricing structure and perspective of our products. So our app and dashboard comes out to $500 each month, and this includes the cost of servers. Then our device will be manufactured at the cost of $59, and this includes the three major components: the Raspberry Pi, camera, and sensors. And then FOVEA AI has integrated a two-phase pricing strategy. Our first phase includes a cost-plus pricing strategy, where we plan on making our money based on the quality, service, and profitability of our product. Then we will shift into the value-based strategy, where we implement our pricing structure and start selling the product based on the branding and reputation of our company. The first phase, it focuses on the cost-plus pricing strategy, where we plan on making the money based on the profitability of our product and the quality and service. Then phase 2, phase 3, phase 4 will focus on the value-based strategy, where we plan on selling the product based on the reputation, branding, and credibility of our company. We will be needing around $153,000 to set up the entire foundation of FOVEA. This includes having a facility to manufacture our product, buying device components and initiating production, and solidifying our advertising and promotion costs, where we will be able to reach the intended target markets of our product and services. After implementing pricing with costs related to manufacturing and app development, we believe we can pull around $185,000 in yearly profits. This includes selling the device in phase 2 and phase 3, data collection, and finally our subscription models. Our projected profit includes $293,000 in projected revenue, where $250,000 of that comes from selling the device, and the rest, $43,000, comes from other monetary models set in place by FOVEA AI.
FOVEA AI has a goal to utilize novel technologies that harmoniously solve large problems like harsh road conditions. Our mission is to allow drivers and cities to benefit from our long-term goal of increasing pothole detection and reducing carbon emissions related to roads plagued with this issue. We will start by specializing in the mobile application development, where we will be able to benefit every demographic we intend to target on a daily basis. Further, through creating privately accessible API keys, we can integrate FOVEA with big, pre-established brands like Google Maps or Waze. Another one of our goals is increasing our object detection success rates. So this will primarily be accomplished through a multifaceted approach, emphasizing R&D strategies like stratified random sampling on real-time road network data to further optimize our algorithms. Now, diving into the business side of things, we believe that we can obtain a market share of around 5 to 10%, because after we launch our product on the market, we can leverage city transportation vehicles to actually help us solidify and expand our services. Investment into the data infrastructure of our company, paired with increased data collection to provide a better user experience, will allow FOVEA to obtain a portion of the intended market and help us accomplish our goal of decreasing the global carbon pollution rates one pothole at a time. I'm going to be going over some of the challenges we have faced in our application development cycle. So, code implementation was a really difficult task, and because we were doing this in an IoT setting, all of the issues we were having got scaled up exponentially. This was because often some of the specifications we required were incompatible with Raspberry OS. Next, we had to acclimate to different command types and data pipelines and actually scaling our application. And so this was where our mentor helped us a lot in actually gaining an understanding of what this does in back-end processes and stuff. Lastly, we had to figure out deployment clusters, so like Docker and Kubernetes, to actually use in our web servers. And in the end, we decided to stick with AWS S3. Next, creating a beautiful UI UX design was a really difficult task. We wanted to really target that user experience and make it so that our FOVEA AI app would be highly influential in helping a person's day-to-day life. The second most difficult thing in this was actually transferring real-time data between databases and user portals and getting our map plugins to work.
FOVEA AI has partnered up with local companies in the area. For example, we've partnered up with Think4Things for the entire IoT infrastructure of our FOVEA device. Then we also partnered up with Macrotech Consulting for the entire AI/machine learning aspect of the FOVEA device. Then we finally partnered up with Dealing Estates for the entire idea of getting in contact with city road networks and analyzing. Thank you so much for listening to our presentation, and make sure you guys stay afterwards and watch our product demos, where you can see the real-life functionality of our FOVEA device and our app. Bye-bye.
So now moving to the actual algorithm itself. So what we've done is we've set up a testing system within my car, and you can see there's our Pi board. This is our monitor, mouse, and keyboard. And what we're doing is we're basically just going to be recognizing how the algorithm is actually detecting the facial model of my test subject. This is a really important finding because if our algorithm can detect faces, we can just use transfer learning protocols through our RNN networks to transfer this learning mechanism to pothole detection systems. So as you can see right now, our person is basically going to be moving around, and it'll be detected through our pothole detection system. And so the reason we don't actually have our pothole system currently in place is because I'm in my driveway and I can't really detect potholes where there are no potholes. And so as you can see, I've just transfer learned this algorithm to help better detect faces. So as you can see, it's better able to detect faces. Like so.
This is how the app will be displayed to our users. The app homepage is initially started with spreading our message of decreasing pollution one pothole at a time. Then the model of our app is very intuitive, where with a single touch, it moves quickly.